Okay, Monday, 10:14. Again, just the front and back. Relative extrema. And there's a lot of words on this page, but we'll just hit the summary here. Do a quick little picture. There's a max. There's a min. It's easy to tell by looking at a picture who's a max and who's a min. But if we didn't have the picture and we only had an equation, things would be a little bit harder. What would you say about f prime in this area right here? What is f prime in this first interval? Sophie, what could you tell me about f prime in that first interval? It's positive. F prime is positive. Nick, what would you tell me about f prime in that second interval? It's negative because the function is decreasing, so f prime is negative. Alina, what would you say about f prime in this last interval?
Positive.
F prime is positive. Okay, so we're almost to the point of the lesson today, and that is if f prime changes from positive to negative, if you change from increasing to decreasing, you reached a max. If f prime changes negative to positive, you've reached a min. That's pretty easy if you're looking at the picture. The trouble is if you don't have a picture, you only have this to go by, and you sort of have to interpret f prime into the graph and think about increasing, decreasing. It's not that bad. Okay, visually it's easy to see the relative extrema when we view the graph of a function, right? The peaks, the valleys. But if we didn't have the graph, then how could we tell where the relative extrema are? Well, that's what we were just talking about. A relative maximum is where the function changes from increasing to decreasing. And this is not like a memorized square. This is like think about it square. If we go from increasing to decreasing, there's a maximum. And if our function goes from decreasing to increasing, there's a minimum. All right, let's look at the point on our graph. Clearly it's a maximum. What is f prime at A? What is the derivative of f at A? 0. The slope of that tangent line is 0. And then the sign of f prime changes from what to what? The sign of f prime, let's see, on this side, Andrew, what's the sign of f prime in here? Positive. And then on the other side, Michael, what's the sign of f prime over here? Negative. So if f prime changes from positive to negative, then you got a max. You can kind of go through the same stuff for point B. The slope is 0. And f prime changes from decreasing to increasing. Wait, I said that wrong. F prime changes from negative to positive, which means f, let's go ahead and write this, changes from decreasing to increasing. So you do have to be careful about which set of words you're using and if you're using f or f prime. So don't say that f is positive or negative or f prime is decreasing or increasing. Make sure you get the combinations correct. We said previously that a cusp or a corner can be a relative extrema. In the above graph, the corner is a relative minimum. Like clearly, it's the valley. Does the sign of f prime change at that point? Call that point C, I guess. Does the sign of f prime change there? So you were nodding your head. Yes, it goes from negative to positive. So, yes. All right, first derivative test. I would say the stars go with more about the title than the content. Like you have to understand the content, but you don't have to memorize the content. Because I think the content is going to make sense when we read it. So let's just jump to this first bullet. If f prime changes from negative to positive, That means we're going from decreasing to increasing. Then F has a relative minimum there. Yes, that makes sense. If F prime changes from positive to negative, then there's a relative maximum there. Yes, that makes sense. If you know what increasing and decreasing and F prime positive and F prime negative mean, it's easy to figure out maximums and minimums. This last one is sometimes throws people off. If F prime is negative on both sides, so that means we are decreasing, level off, and still decreasing, well, that's not a max or a min. Same thing if we're positive on both sides, then we are increasing, level off, increasing again. That's not a max or a min. Okay, the rest of this is pretty quick and easy here. Relative means the same thing as local. Relative and local, those mean the same thing. Relative extremum, local extremum, refers to a max or a min, like the extreme value, the extreme high or extreme low. And then some plurals. Plural of minimum is minima, plural of maximum is maxima, plural of extrema is extrema. Don't turn the page yet. Here's the process we'll use. We'll first find critical points. So we've done that before. Then we'll put our critical points on a number line. And after the number line, or the number line will tell us increasing and decreasing intervals. All of that we did Friday, right? That's old news, old stuff. We've done that. The new stuff, again, if you get all that, the new stuff isn't really that difficult. Once you know where your increasing and decreasing are, then you can find your maximums and your minimums. And that's sort of the point of today. So, today itself, not really that hard. If a derivative changes from positive to negative, it's a max. If the derivative changes from negative to positive, it's a min. It's just all of the stuff leading up to that. We have to make sure we can take a derivative, understand the number line, pick points on the interval, plug them in, find the intervals, then we can make conclusions about maximums and minimums. So I feel like the concept today is pretty easy. It's all of the background process getting there that sometimes messes us up. Okay, example 1. Find all relative extrema of that thing and designate each as a max or a min. Okay, so maybe I should have put that little diagram on this page. Critical points lead to a number line, lead to increasing and decreasing intervals, lead to relative extrema. There it is one more time. So it's that last step that's the new thing, but the old stuff is still a lot to think about. So critical points, that's where the first derivative is 0 or undefined. So I need a derivative of that thing. That thing has 3 pieces. So we'll pick 3 people. Naomi, how about the derivative of x to the 4th? 4x cubed. Ethan, the derivative of minus 32x? Minus 32. Whoops, not minus 32x. And then Mr. Wolf, the derivative of 4 is 0. Everyone knows that, but I'm going to keep asking it to hopefully avoid making that mistake. All right, let's set that equal to 0. Factor out of 4. Oh, they were nice to us here. I was worried about x to the 4th in there, but x cubed equals 8, x equals 2. That's my critical point. So that might be a max or a min. But I don't know that yet until I do the number line and the intervals, and then I can tell if it's a max or a min. So number line, x equals 2. Let's plug in 0 and 3. When I say plug in 0 and 3, where are we plugging in 0 and 3? Into f or f prime? F prime. Because I want to know where f is increasing or decreasing. So I'm going to plug them into f prime. Probably the factored form, but you can plug it into either form, factored or not. If I plug in 0, I get negative. If I plug in 3, well, that's a little bit harder, but 3 cubed is 27. 27 minus 8 is positive, times 4 is still positive. Okay. Naomi, if f prime is negative, what does that tell me about f? If f prime is negative, what does that tell me about f? Don't worry about max and mins. Just if f prime is negative, that means the slope, it's going down, and the fancy word that we'll use is decreasing. But going down is fine. Kyler, if f prime is positive, what does that tell me about f? It's increasing. Okay, I think I'm ready to make a conclusion, Audrey, about what's going on at x equals 2. What's happening there? Max or min or neither? Min. Some people even draw the picture. It makes it even more clear. If we go from decreasing to increasing, well, pretty sure there's a minimum there. So minimum, I'll say local minimum because I don't know what's going on elsewhere, but I just know that at 2 we're at the bottom of a valley here. Local minimum at x equals 2, because here's the justify part. And the justify, you always want to use a calculus justification. So it wouldn't be wrong to say f changes from decreasing to increasing. It would be better to say f prime stuff. So f prime changes negative to positive. So there's my justify. Okay, let's reread the question. And I intentionally left something out. I didn't answer this question exactly how it was asked. Find all relative extrema points of that function and designate each as a relative max or relative min. Justify your answer. Why is my answer not quite complete? Do you know? It's not even a calculus thing. It's more of an algebra thing. Like I got the max or min. I said it was a minimum. It's not a maximum. I justified. I got that. Designate. We did that. Find all relative. We found all of them. There was only one. There's only one more word that is going on in there that I haven't done yet. Points. So what else do I need to find? I mean, I've got the x value. I need to find the y value. So the point is at 2 comma. How am I going to find the y value? How am I going to find the y value? Pick on somebody. Lauren, if I know the x value, how am I going to find the y value? Perfect answer. We're going to plug in 2 into f of x. Not into f prime. That would tell me the slope at f, which we already know is 0. I want the y value at f, so I need f of 2. So let's see, 2 to the 4th minus 32 times 2 plus 4. Well, it's the end of a problem. I suppose I could just safe stop that and write that whole expression as the y value, and that would be okay. I mean, I don't want to mess up taking 2 to the 4th. 2 to the 4th is 16 minus 64 plus 4. Yeah, you know what? Feeling lazy. I don't want to mess this up. That's an acceptable answer. It's kind of ugly looking, kind of weird looking. If you had to graph it, you'd need to find the actual point, but that's an okay answer. Safe stop that thing. I really don't know what it is. I'd have to do the... Yeah, you like free response questions now because you can safe stop things and be done. All right, number 2. Find all values of x. Oh, so already, how is number 2 different than number 1? Find all values of x versus find all points. So I won't have to go back at the end and plug in. My x values will be enough. At which this thing has a local max or local min on this interval. So I'm only looking 0 to 2 pi. State whether it's a max or min and justify your answer. Again, justify is always going to be f prime changes positive to negative or negative to positive, depending on if we got a max or a min. Okay, so back to the process. Critical points gives me my potentials. Put those on a number line, check the intervals, and then I can find maximums and minimums. So job 1 would be a derivative. So Owen, how about the derivative of x? 1. And Dana, the derivative of 2 sine x, 2 cosine x. So let's set that equal to 0. That will tell me my critical points. And my critical points are my potential maxes and mins. So cosine of x equals negative 1/2. Getting low on popsicle sticks here. Do we really want to call out somebody for a unit circle value? The people who haven't been called yet are like, no, don't. Everyone else is like, sure. I've already been called. All right, I'm not going to pick on them. Where's cosine negative 1/2? Two pi over 3. And where else? Once you got that one, you can probably find the other one. What's the other one? 4 pi over 3. We got the right answers. Don't need to argue about who got credit over there. Okay, so those are my critical points. Leah, what do I do with those critical points? Like, how am I going to figure out if those are maxes and mins? Number line. So 2 pi over 3, 4 pi over 3, something less than 2 pi over 3. Let's go 0. How about between 2 pi over 3 and 4 pi over 3? Pi. And then bigger than 4 pi over 3. I guess we could do 5 pi over 3, but 2 pi would probably be easier. And then, Jessica, where am I plugging those into? How am I going to use those values? Am I plugging them into y or y prime? Y prime. Because I want to know if we're increasing or decreasing. Because that will tell me maxes and mins. So y prime, which was right here. Oh, this might be a little bit yucky. 1 plus 2 cosine of 0. Oh, out of popsicle sticks. Must have called on everybody. What's the cosine of 0? Cosine of 0 is 1. So 1 plus 2 is 3. All I really care about is positive. If y prime is positive, what does that tell me about y? It's increasing. All right, let's plug in pi. 1 plus 2 cosine of pi. Cosine of pi, pi's over there. That's negative 1. 1 minus 2 is negative. And if y prime is negative, that means y is decreasing. And then, hey, 2 pi and 0 should give me the same thing, right? Because that's the same spot on the number line. So this one's going to be positive as well. Okay, so what's going on at 2 pi over 3? Max or min? Oh, it'd help if I drew the pictures, right? Increase, decrease, increase. So there's a maximum at x equals 2 pi over 3. And what's my reason? What's my justify? F prime changes from positive to negative. That would make a max. And then what's going on at 4 pi over 3? Minimum. And then the same type of reason, but F prime changes negative to positive. All right, we'll stop there. We may work number 3 tomorrow. Assignment is worksheet 2, 9 through 16. Again, it's all the same steps from a week and a half ago, but that extra step at the end, once you have increasing and decreasing intervals, it's easy to see where the maximums and the mins are.